Meet quite regularly, frequently. We were together in Copenhagen in December 2009. We witnessed, I would say, the failure when it comes to reaching an agreement on the climate. Maybe our expectations were too high, but however you look at it, it was of course a disappointment, because the world desperately needs to start with a binding agreement on climate change. A couple of months afterwards, we started to experience, on the one hand, that the media attention when it came to climate change in general almost disappeared. And the only articles that were appearing were articles that more or less dismissed climate science and told whoever wanted to listen that it was just nonsense all of it. And we talk, of course, about deniers of different kinds. I know that both Johan and I tried on a couple of times to write responses, but they were not really welcome. It was as though the media felt that the years leading up to Copenhagen, they'd given enough space for those who are concerned about climate change and environment. Now it was time for the others. And we felt very, very upset, very frustrated. And we said to ourselves, we must respond, because there were so many arguments that didn't hold true. And that was really the starting point of this book. But it didn't take long until we realized that, no, to write a book only about climate denial is not really worth the effort. So we have 2 chapters dealing with that. The rest of the book deals with the much broader picture, which has to do basically with the relationship between human society and what we would call the natural systems. And the fact that there is a big denial going on in society, not least among decision makers of different kinds, to really agree and accept and to take action from the point of view that we are totally dependent on healthy natural systems for our welfare, for our well-being. So that was really the purpose of the book. And here you can see the key messages. To clarify a concept which Johan will explain more in detail, called the planetary boundaries, which is a groundbreaking new research area. To demonstrate a set of very complex and interconnected risks, climate change, ecosystem decline, and resource constraints that humanity is facing. To underline the specific risks we face in terms of energy security, to challenge, and that's the title, to challenge all those decision makers that refuse to discuss the dilemma that we experience when it comes to conventional growth. To challenge specifically the climate change deniers, to pose a very serious and important question: how much is lagom? Going back to the Dag Hammarskjöld Foundation booklet in 1975. And then last but not the least, to try to chart out some of the elements in a strategy for sustainability. We start the book by stating that we live above our means, both in the money economy and with regard to nature. And probably no generations before us have borrowed so heavily from the future. Governments, whether we look at the US, parts of Europe, and in other parts of the world, as well as households. That doesn't mean that there's something inherently wrong in borrowing money and invest based on loans. But you have to make the distinction. You have to be sustainable in what you do, not just consume or eat out of the future. So the money economy is a big problem, and we all face it daily in terms of debates in the newspapers. And then we have the other side of the coin, which is what we really try to bring to the fore. The environment space is shrinking. Climate change is one example. 2/3 of major ecosystems are used beyond capacity or overutilized. You can do that for a while, but not over a long period of time. It's like money in the bank. If you take more than the interest, you eat up the capital. We have the planetary boundaries, and then a new set of problems, not you, but for most people. Peak oil, peak phosphorus, peak rare earths. That certain of the so-called finite resources are starting to become constraints for our development. And we stress that there is a lot of denial going on in society. And there are several myths being entertained, like the perception that there are no resource limits, and if there are, the problems will be fixed by a combination of price and innovation. Like the notion that the environmental conditions, by some automatic mechanism, improve when the economies grow. You have the so-called inverted Kuznets curve that the World Bank, most banks have been entertaining and sort of subscribing to over the decades. And of course, local pollution very often is being addressed quite effectively when economies grow. But if you look at the global picture and look at the overall picture, I don't think you have to be a Nobel laureate to realize that we are really experiencing problems. And that the more GDP grows as presently structured, the more we extract resources from Mother Nature. And then, of course, this idea that you can discount values in relation to climate change and environmental degradation, implying that there is no risk for tipping points.
Yeah, this is, of course, a very challenging book to write from a scientist's perspective. Quite unusual book, in fact. And the reason to do it from my side is not only to have the great privilege of writing a book with such a great person as Anders, it is also because of a frustration coming out of a reality that the denial we're addressing, as Anders points out, is not only the denial within climate, and it's not only the denial that if you put all the environmental issues on the table, it's clear that humanity faces a much, much larger challenge than previously thought. It's also the denial that even science itself is not connecting the dots, and particularly we're not able to connect the dots between the social and ecological interactions. And I think many of us in the room here feel this all the time. I mean, just the very simple fact that we now have empirical evidence that we are at ecological overshoot in a situation where we're 7 billion people, committed to 9 billion people, where 80% of the world population in fact have contributed very little to the problems we face today, and have a right to development, and are actually on a very, very rapid momentum towards aspiring to a lifestyle which is largely the unsustainable consumption patterns which is represented by those, the minority that cause the problem. And if you put all these cards on the table, there's clearly a vast denial also within science. Now, how does science deal with this? Well, what we address in the book is the very challenging and provocative issue that even science tends to say, deny or downgrade some of the risks facing humanity. And we portray this a bit like the Roman legions, you know, that academic institutions, they're wonderful, like this university, but they tend to be very conservative, and they tend to work as a collective under their shields. And then if somebody questions the kind of mainstream central view, like a soldier throwing himself out on the battlefield, he's knocked down very quickly often, and the academic institution remains under their shields. And we're trying to open up that shield a bit to say, well, perhaps it's time for science to actually be a bit more integrated in its way of communicating some of the challenges we're facing. And we take a couple of examples, in fact, that our critique on the IPCC, you know, in the months after COP15, the critique on IPCC, as you know, was that IPCC exaggerated and that there was problems with the way it analyzed data. And as you may know, the international commissions that were put in place have freed IPCC on all accounts. Our critique of the IPCC is in fact the reverse. That IPCC in many cases is underestimating the risks and is not willing, in fact is in a way compromising science because of its willingness to also be more attuned with what is politically possible to do in a situation where the scientific necessity is very, very much more dire, and we'll come back to that. Now, the evidence behind the scientific drama, as I'm sure you're aware, comes out of a very, very seminal synthesis of the great acceleration of the human enterprise. And you may have seen these hockey sticks, and the most common one is the upper left hand, which is the one we all know, the carbon dioxide hockey stick. But the drama is, as you know, and this is not hypothesis or theory or models, this is empirical observations. And empirical observations of almost any parameter that matters for economic growth and human well-being shows the same pattern. So what you see here on the wall is nitrous oxide, methane, deforestation, overfishing, land degradation, air pollution, and so on. And the drama is that the x-axis here goes from 1750 till today, so it's the Industrial Revolution period, and it all bends in 1955. So 10 years after the Second World War, we move off into the momentum, which is now at the point of the top of this acceleration curve. Now, Niclas mentioned Paul Ehrlich, and as you all know, in the late 60s, the Limits to Growth report came out, the population bomb by Paul Ehrlich, Rachel Carson's Silent Spring, and they warned the world at the point where we had barely started the journey. So they were shot down, but you could also argue that they had very little empirical evidence to defend their case. Now we're up at the top, and there's no excuse for inaction. And most science shows that we need to bend these curves very rapidly. In fact, we may have entered the most decisive decade in modern human history, the decade where we need to bend all these curves simultaneously. And that led us to gather, from the Swedish initiative, to gather some of the world-leading global development change scientists to ask the question, are we as humanity threatening the stability of the Earth system? Because already the Nobel Prize winner Kvarnström in 2004 pointed out that perhaps this hockey stick pattern indicates that we may be pushing ourselves into a new geological epoch, moving out of the Holocene into what he baptized as the Anthropocene, anthros for humans, proposing that we humans are the largest geological force of change on the planet. Now this is of course a very dramatic statement, but what we realized is that that research on the pressures on the planet has never been combined with the science of the risk of tipping points, the risk that these pressures, that the response from the Earth system may in fact not be linear, but may be non-linear, and that we cannot any longer exclude sudden, abrupt, and even irreversible catastrophic change. And if you realize that, and as you know, we're starting to see examples of that, for example, in the Arctic, with very rapid, unexpected melting of the ice. If one combines these two insights, the question was, what is required to preserve a desired stable state of the Earth system? And the answer was 9 planetary boundary processes, which we won't go through in detail, but the key message here is that it's not only climate. And that is, in a way, obvious, but we're starting to see empirical evidence that these processes, including biodiversity loss, land use change, freshwater use, interference with the big nitrogen and phosphorus cycles, air pollution, stratospheric ozone layer, these are interacting at the global scale. It's so dramatic that you can today say with scientific support that we may not be able to achieve the UN Millennium Development Goals because of global environmental change, which of course is a totally new agenda for human development in this situation. Now in terms of climate risks, this is the famous amber diagram of risk to illustrate where science is moving. To the left here you see the knowledge base at the 3rd assessment of the IPCC. So this is 10 years back, and you see in red high risk and white is low risk of global average warming from 0 to 5 degrees Celsius.